Alright, hopefully we'll make this a quick one. Here's an example from Alex. I want you to note with me, I didn't even write down the word problem because we don't really even need to read it sometimes because the notation makes what they're looking for obvious. So we can just begin filling in what's missing. And what's missing is what should be opposite this 0.5. And the answer to that is simple. It's another 0.5, right? Because they have to add up to 1. Here, the 0.55, and this has to add up to 1, so that's a 0.45. This is a 0.25, so this is a 0.75. See, super easy. And we're done with most of it. Now we just have to multiply. So 0.55, or 1/2 of 0.55, is 0.275. 1/2 of 0.45 is 0.225, and if you do a check there, you can see that both of those add up to 0.5. Half of 0.25 is 0.125, and half of 0.75 is 0.375. It's so nice when this is a 1/2. It's easy to calculate. Now, they want to know what is the probability that a randomly chosen student receives a grade of B or higher. So I can assume that that is a B and that this is not a B. This is a B or higher, this is not a B or higher, so it must be a C or lower, right? So we're not going to look at this one or this one. We're going to take these two and add them together. 0.275 plus 0.125 is 0.40, and that would be the answer we put in Alex. Let's do another one. So what I'm going to do first, so let's click on it, tree diagrams for conditional probabilities. That's in the review tab, and you can see they have all this info here. Don't necessarily have to read it until perhaps the end if it's not clear, if I can't make an educated guess, but I do definitely need this info. Oh, you know what though? I don't really even need to copy it here because this is one of those things that you can do right in Alex just by eyeballing it. You don't have to work it out on a separate sheet of paper. But since I have it here, I'll use the fact that it's here. Okay. Let me get rid of that. I'll make this bigger. So we have this. Down here, you see a 0.35. Here you see a 0.4. Here you see a 0.6. So first I'm going to fill in this. This is 0.65 because it's got to add up to 1. These two have to add up to 1, so this is a 0.6. These two have to add up to 1, so this is a 0.4. And now we just multiply. 0.65, I'll do 0.65 times 0.4, which is 0.26. And if that's 0.26 and that's 0.65, that's 0.39. That's not too bad. Yeah, that's right. And then 0.4 times 0.35 is, let's say, 0.14. And then this is 0.21 because they have to add up to 0.35. And now that I have that information, I can just go ahead and put that in Alex. And you can see how easy it is if you're, got some math abilities. If you don't, you got a handy dandy calculator, you can work it out. So I'm just gonna go through this and put these in. So this was a 0.65, this was a 0.6, a 0.4, this was a, well, this one was a what, a 0.26, which made this one a 0.39, which made, and then this one was a 0.14, so this one was a 0.21. Now they want to know what is the probability that a randomly chosen card did not require brake repairs. So we can assume B's are required brake repairs and not B's are did not. So it's going to be 0.26 plus 0.29 is 0.49, so 49%. And for the ones where it's not clear, you just go quickly up here and look where it says Let B denote event that a randomly chosen car required brake repairs, and not B denote the event that a randomly chosen car did not require brake repairs. So it's pretty straightforward. Just fill that in, you hit next. Hopefully you get it right. Uh-oh. They're saying I messed up somewhere. So, where'd I mess up? Every now and then I get that. I don't think it's up there. I don't think it's down there either. So where could it be? 0.26. Oh, 0.47. Can't add. I mess up the easiest part of the whole problem. Okay, there we go. And it says I've mastered it, but I can practice it again if I want. And for your sake, I'll do it one more time. So here we go. Here's the problem. You got a 0.2 there, which means you must have a what there? 0.8. Very good. You got a 0.7 there, which means you must have a what here? 0.3. If you got that, good job. You got a 0.15 here, so you must have a 0.85 there. Now we begin multiplying. 0.8 times 0.7 is 0.56. If that's a 0.56, this is a 0.24, because I'm looking at this number here, and I know they have to add up to 8, but you can also go 0.8 times 0.3 is 0.24. 0.2 times 0.15 is 0.03. Be careful of your decimal places. And that makes this 1.17. But of course you can check that by multiplication. What is the probability that a randomly chosen voter voted for Hector? Assuming that H represents people who voted for Hector, we have 0.56 plus 0.03, which is 0.59, and we are done. Hopefully that helped you out, and that's it for this video.